Alright, in this video we're going to compare mil dots and other ranging reticles. And we're going to get a good idea of which system you're going to want to use under different circumstances. Now there's quite a diversity of different ways to get your range to the target. It's going to be very important to get as close as you can because, as we talked about before, at extreme long ranges, your danger space is going to be somewhat narrow. And missing the range could throw off your shot enough to be a complete miss. So we're going to go over particularly different ranging reticles, including mil dot scopes, binoculars, and different spotting scopes. We're going to compare those range finding methods to the use of lasers. We're also going to discuss GPS, aerial photography, and maps. And we're going to compare all these different things in regards to how to use them, when they're appropriate to use, their advantages and their limitations, so that you can have a good idea of how to properly employ these things and how much weight to apply to any of these systems that you're going to rely upon. So let's start off first with the most widely known method of range estimation for long-range shooting, and that's mil dots and other ranging reticles. Now there are a diversity of ranging reticles available today. When we're talking about mil-scaled binoculars, the M19 comes to mind, and even the new M22 Steiners come to mind. If you've ever looked through a pair of those, you're going to notice that they have a mil-scaled reticle going through. They have a horizontal and a vertical axis on that reticle, and the hash marks are separated in kind of crude increments. The larger hash marks are 10 mils apart, and the smaller ones are just 5 mils apart. Now, these kind of exhibit large ranging error probabilities, and that kind of renders these inappropriate for the ranging of small targets when applying precision rifle fire. These things are really best for directing fire support and for more crude ranging applications on the battlefield involving field artillery and things of that nature. But these do have some limited usefulness in correcting precision rifle fire. You know, if you're adjusting your shots and stuff like that. But as far as ranging is concerned, these aren't going to be very accurate. And we'll get into more of that in a little bit.
2 inches.
Spotting scopes with ranging reticles are also available, and these are an excellent tool for ranging targets and for correcting precision rifle fire. Spotting scopes with ranging reticles typically feature 20 or 30 power magnification. A lot of them are fixed because it's the eyepiece that you buy that has the scaled reticle in it. And we'll go over reviews of different spotting scopes that fit these criteria, but these do make measuring targets much easier. That you have a spotting scope mounted on a tripod, you got a real steady platform, and it's pretty easy to see the mil scale, and you can get a real precise reading of the target. And these are very, very highly recommended for other purposes as well, particularly for correcting fire. And we'll get into more of that when we're talking about spotting the shot later on. What usually comes to mind when you mention mil dots or other ranging reticles are rifle scopes with ranging reticles. And as you're very well familiar with by now, that there are a whole lot of different designs for different applications available out there. The one that's most familiar to people is probably the classic mil dot reticle. This is a pretty simple, intuitive design that enables really precise measuring of even small targets. And these are actually great for ranging targets when small differences in target size need to be discerned. Nice thing about the classic mil dot is that human spatial perception is such that the circle dots are kind of intuitively superior to hash marks in the normal scaled reticles, and that circles are easier to subdivide into smaller pieces than are just basent line segments. As you know, if you just have a bunch of different line segments laying around, that can have some optical illusions, and it can really throw off your spatial perception. Also, the simple layout of a standard mil dot reticle makes it pretty easy to remember how to use under high pressure situations. And that's one of the reasons it's been used for such a long time, is they took into account a lot of those different factors. There are, however, other mil scale reticles out there, and they offer a diversity of features. There's a lot of different models. Some of the features are additional holdover or quick ranging brackets, depending on which reticle you're looking at. And like the MP8 has a lot more holdover available in it, which is nice for applying hold off. But when it comes to ranging, the complexity of some of these different layouts may render them a little more difficult to use under high pressure. So some of these reticle designs are not so much suited with ranging in mind, but more for hold off values in mind, or for correcting fire in mind. Just keep that in mind. Okay. There are some Horus pattern reticles out there. You might have seen those. It has the whole grid pattern laid out in there. And those are an excellent design for correcting fire and for applying hold-offs especially. And these work pretty much the same way as other scaled reticles as far as ranging is concerned. But the main advantage to these is really in applying precise hold-offs or for correcting fire. When doing so, they can reduce error due to poor spatial perceptions on the behalf of the shooter, but they're not really particularly designed to be advantageous for ranging applications. So when you're looking at all the different reticle designs for rifle scopes, the mil dots or some of the other ones that actually lay out shapes in the reticle are easier to subdivide and might be a little better as far as the ranging aspect is concerned. The mil quad reticle actually is not bad at all. That's a very intuitive design as well. And there are some that employ different thicknesses of hash marks. And some do have a quick ranging bracket feature, which can help too, but those are somewhat crude for precise rifle fire applications. So that's just a general overview of the kind of ranging reticles we're going to be talking about. Now let's give you a quick idea of how these things compare. There are different kinds of ranging reticles. They're not all based on mils. As you know by now from our other videos before this one, long time ago we talked about mils and degrees. Radians is one system of angular measurement, and degrees is another system of angular measurement. They're both angular systems of measurement. 1 milliradian is simply 1/1000th of a radian, which there's like 6 point something radians in a circle, okay? And when you're talking degrees, there's of course 360 degrees in a circle, and if you subdivide 1 degree into 60 parts, into 60 minutes, you have a minute of angle. So that's the difference there. They're both angular systems of measurement. So if you want to put the unit of measurement 1 mil up to 1 minute of angle, you're going to find out that 1 mil is equivalent to approximately 3.438 minutes of angle. So at 100 yards, 1 mil is going to be about 3.6 inches, and 1 minute of angle is going to cover about a little over 1 inch. And you can look at the details in the videos we talked about earlier on those. But if you want to compare the click increments on your optic when you're talking about the turret adjustments, most milliradian-based scopes are in 10th MRAD click units, and 1/10 of a milliradian is going to approximate to about 0.36 inches at 100 yards. And of course, a 1/4 minute of angle click adjustment on a minute of angle scope is going to be 0.26 inches at 100 yards. So they're 72% familiar approximately. The minutes of angle is a tiny bit more fine of a measurement. So that's why some guys do like the minutes of angle. A lot of guys like the mils better because they are subdivided in units of 10, which is easier to divide into other numbers, and just the spacing of mils seems more advantageous for other applications to some people. That's user's preference kind of deal. Whichever system you're using, the methodology and how to use these things is basically the same, okay? And we're going to show you how to do this. Now, you're going to be using these scaled reticles, whether it's a mil scaled reticle, a mil dot, or a minute of angle scaled reticle, whatever you're using, you're going to have a formula, and you're going to measure the target with the reticle. And if you know the target's dimensions in size, you're basically going to plug that information into the formula, and it's going to give you the range. And here you can see that the range determination using mils is quite a simple system. You simply take the target size and whatever units you want to use, and whatever you want your output to be in range, you multiply that times 1,000, pretty simple, and you divide that by however many mils it takes up in the scope. Okay? So if your target is 1 cubit in size, you take 1 cubit times 1,000, and you divide it by however many mils it is in the scope, and that's going to equal your range in cubits. If you don't like using cubits, you like using yards, you can take a 1 yard size target times 1,000, divide it by how many mils it is in the scope, it'll spit out your range in yards. Or you can use inches or feet or meters or whatever you would like. Now, for all practical purposes, if you break this down and you want to use a more usable system of measurement for measuring your targets particularly, because most of us aren't familiar with some of those units of measurement when we're talking about target dimensions, I'll do the algebra for you here, and here's a formula you can use. If you know the size of your target in inches, you take that number and you multiply it by 25.4. That's basically a metric conversion and multiplying it by 1,000, okay? So you take your target size in inches times 25.4, you divide whatever that number is by however many mils that takes up in your scope, okay? That'll give you your range in meters. If you're using a minute of angle scaled reticle, you take your target size in inches, multiply it by 100, and divide by however many minutes of angle it takes up in your scope. And that will equal your range in yards. So as you can see, these formulas are relatively simple to use. And whichever optic you're going to use, you're going to want to write this formula down on every piece of paper you're carrying with you in the field so you don't forget it. Under pressure, that does happen sometimes. Now, the more practice you get in, this is going to be second nature. You're not even going to think about it. But at first, especially, you're going to want to carve this into your arm. Tattoo it on your hand. No, don't tattoo it on your hand, but write it on your hand with a Sharpie or whatever you got to do. Get your formula memorized. And I'll post these in the description box as well for you. But how to use these, okay? Now, the best way that you're going to do this in the field is, here's how it's going to go. You're going to collect and record the dimensions of various potential TRPs, those are target reference points, that you're going to potentially see in your area of operations that could be used to range distances to various places or target areas on your range card. And what that means is you're going to go out and anything you might possibly see in the target area when you're in your area of operations, you're going to go ahead and measure it ahead of time. For example, fence posts. You can measure those, write those down in your book. What's the typical height of a fence post? 48 inches or something like that, okay? Or if you're operating in urban terrain, what's the average height of a door on a house? Like 80 inches might be that unit, or whatever area you're operating in, okay? If you're going to be shooting at a deer, you're going to memorize the dimensions of the target itself. A deer's chest might be 18 inches deep. So you're going to write down all these different potential target sizes and target reference point sizes. You're going to measure them with the tape measure, look up how big they are, write it all down in your dope book. Okay? Now what you're going to do is you're going to have all this information ahead of time, all your different potential target sizes. And you're going to, when you're drawing up your range card, when you establish your final firing position, you're going to be drawing up a range card which shows how far all the different potential objects that your target could be standing next to are going to be. And you're going to designate and range all your different target reference points ahead of time before the target ever gets there. This is going to enable you to deliver fire really quickly as soon as a target does present itself, in proximity to one of those target reference points that you predetermined the distance to, okay? Now, if a target pops up at an unknown range that's not near one of these target reference points that you have already figured out the range to, you may have to actually range the target itself, assuming that you do know its dimensions. And that's where that dope book comes in handy, your little notebook. Make sure you do a lot of data collection before you're deployed to a particular area, and that will give you some good information to have. You're going to only be able to do it before the mission starts. After the mission starts and you've established a firing position, you're not going to go wandering around in the target area measuring stuff, okay? That's not going to be a good idea. Just keep that in mind. You're going to have to know the dimensions of different target reference points. So let's give an example of how we would measure a potential target or a target reference point in the field. Okay, so here we're looking at a 12-inch steel plate. So we know the target dimensions because when we set it up, we measured it with a tape measure, okay? And we determine when looking at it with a rifle scope, and we're getting as steady as we can, and we're going to want to be as close as possible on our measurement that this is 1 mil across. Now, as you can see, this is a mil-scaled reticle. It's not the mil dot, but you're going to have to know your reticle, okay? You're going to want to look at the manufacturer's data because each reticle is going to be different. Different manufacturers have different sizes for different hash marks, different thicknesses of lines, and so forth. So you're going to study your reticle and probably have a cheat sheet if you have a real complicated reticle that tells you what everything is. But you're going to want to get as close as possible. When you're talking in units of mils, you're going to need to be really close. You're going to want to get within 1/10 of a mil. And if you're a well-trained expert in this field, it's not going to be too hard to get within 1/10 of a mil as far as ranging your target. So we range this 12-inch steel plate, and so we take 12 inches multiplied by 25.4 was what the formula said. We're going to divide that number by 1 mil because that's how big it is in the scope, and that's going to give us our range in meters, which in this case is only 304 meters. That's pretty much point-blank range. Smaller targets, so we will adjust for it. And don't forget your wind, and there you go. Look it up on your firing table or your calc form or whatever you're going to use, and go ahead and touch her off. Let's look at another one just to get the hang of this, and we'll discuss it in more detail. Here we have an Iron Maiden target, steel target, okay? And from top to bottom, we measure it at being about 0.8 mils. Now, if we look at the mil dot scope here, this is one that's really, like I said before, nice to use because the circles are going to make it easy to subdivide smaller units. Now, from the center of the crosshairs to the center of the first immediate dot is going to be exactly 1 mil in angular distance, okay? Now each dot is going to be 0.2 mils across, okay? Now, this is for a standard U.S. Army style mil dot reticle. There are different style mil dots out there that you need to be aware of. If you have a goofy looking one or if it's different, you're going to want to look up the specs on it. But so if you consider the size of the dot being 0.2 mils apart, you can conclude that from the center of the crosshairs to the edge of the first dot would be 0.9 mils. And if you look at the target here, it's not quite reaching that far. It's just a little bit short of that. Well, you can imagine the distance from the center of the dot to the edge as being 0.1 mils, and you can just use your spatial perception in your brain to connect the dotted line, visualize, and you will see, yep, that sucker looks like it's 0.8 mils tall. Okay? And if you want to confirm that, if you're familiar with your mil dot design, you can know that in between two dots, if you go from the inside edges of two dots, from the center of one dot to the center of next, you're going to have exactly 1 mil. So from the inside edge of one to the inside edge of the other is going to be subtracting 0.2 mils because you have 0.1 on one and 0.1 on the other, right? And so that's going to give you 0.8 mils. And so that's a real good way to conclude for sure that, yep, that target is 0.8 mils tall. So that's what's nice about the mil dot reticle. So we take our Iron Maiden target is 40 inches in size, times 25.4 is the number we told you to use. Divide by 0.8 mils. That's going to give you a range of 1,270 meters. Go ahead and look up your firing solution, dial it in, and send it. Okay, let's look at another one here. Now, the Iron Maiden setup is kind of set up to represent the spatial unit of an enemy combatant that's easy to see, from crotch to head particularly. Now, most of your enemy combatants are going to be approximately a 40-inch tall target, maybe a little smaller. That varies, as the critter varies. But that's just... as a general rule of thumb, you can consider from the crotch to the top of the head is going to be about 40 inches, okay? And it's probably better to use that. Some guys in some ranging reticles that have the quick ranging brackets are set up to measure the full height of the human silhouette. And that is can be more problematic as the human is usually not fully exposed. If there's grass, you're not going to see his feet. If he's standing behind any kind of defilé, you're not going to see his legs or his knees or other parts. So it's important to know the various dimensions of different parts of your target, okay? And shoulder width is an important one to know. It's usually from 18 to 20 inches on average. But from crotch to head is a real common one to use. And of course, the bigger target you have to mill, to measure, you're going to get a bigger base on your triangle. This is all just basically trigonometry. So the bigger base you have on your triangle, the more accurate your measurement is going to be. So you're going to want to always take the largest one possible. But on this example, we have from crotch to head, we're measuring about 2 mils, okay? We're assuming that the target size is 40 inches times 25.4 divided by 2 mils, and our range to this target is 508 meters. Now, at that range, crotch to head method is going to work fine, even if the size of your target's a little bit off, because 500 meters ain't really that far. You do have quite a large danger space there, some cushion of error. So you always want to keep all these different things we learned in mind when we're doing these different scenarios. Let's look at this Iron Maiden again. Now we have a different scenario. This is more of a video here, and this is demonstrating the challenge of keeping your reticle steady to mill the target. This is what it's going to look like in the field when the higher the magnification, the more exacerbated this is going to be. It's going to appear to be wiggling more, just because you have wind, your pulse, and the more steady of a position you can establish, the better off you're going to be. But in this target, we range from top to bottom. We're measuring, it's going to be 0.9 mils. So 40-inch tall target times 25.4 divided by 0.9 mils equals 1,128 meters. And what we can see here is that the first Iron Maiden that we ranged was 0.8 mils. This one's 0.9. And we have quite a big difference in the range, over 100 meters difference. And at these long ranges, that's going to be a problem, because you're going to have to be very, very precise with your mil reading, okay? 1/10 of a mil gave you a difference of over 100 meters. So that's important to keep in mind, because your danger space is going to be significantly less than 100 meters at those distances, okay? And so you're going to have to be very, very precise the further out you get. And beyond a certain point, really, this is going to be largely ineffective for range determination, for final range determination. So let's look at all the different advantages of using scaled reticles and mil-dot reticles to range our targets. There are some advantages to this system over other systems that might be more accurate technically, like when we're talking about lasers in particular. Some of the advantages of scaled reticles and mil-dot reticles over lasers and other methods are that you're going to have a positive range bracket acquisition. And what I mean by that is that when you're using optical systems or you're visually looking at the target and measuring it, you're drawing the base of the triangle is the size of the target. And so you are going to be definitely ranging the size of the target. Now, when you're using other systems like a laser, you're not always sure. There are certain things, and we're going to go through the long list of challenges you have when using a laser rangefinder. But you're not always positive that you're getting the reflection off the actual target and not something in front of the target, something behind the target, or you have the beam being deflected by atmospheric effects. You never can tell for sure. So with the mil-dot or with the ranging reticle, you can get a positive range bracket acquisition, and this is going to be good for confirming that whatever you got on your laser or perhaps your GPS or your maps is not crazy, and that the laser, in fact, is in the right ballpark. So this is kind of a double-checking method when you're talking long ranges. Medium ranges ain't going to be a problem. Another advantage to optical systems like this when you're talking about mil-dots or ranging reticles is it's a passive way of range finding. It's a passive range finding system, which means it's not emitting any kind of light. And that's going to be very good, because as you're going to see when we discuss lasers, there are certain technologies out there that are going to detect lasers. And so for certain applications of fire, where you have a sophisticated enemy, you are not going to want to be emitting light if you can help it. So sometimes on the battlefield, you're not going to want to use a laser, and you're going to be limited to using your reticle. Another advantage of reticles and mills are that it's always going to be available. You're going to always have your rifle optic attached to your rifle, hopefully. Now, if you're going to be using open sights, well, then you're going to have to use something else. But for most part, you're not going to lose track of your rifle with your scope on it, okay? And one of the other big advantages, too, obviously, is it's not dependent on batteries, and it's going to operate for extended periods of time without battery resupply. The reticle is always going to be in there, hopefully, unless something really bad happens. Now, there are limitations to this, as we kind of hinted at here. The major limitation is that you're going to have to know the target dimensions, or the dimensions of another nearby object. So that's going to require a lot of mission planning. You're going to have to keep a good log when you're drawing up your different TRPs of all your different potential target dimensions. Another limitation is you're going to have to not only know those target dimensions, but the full known dimensions of the object being ranged must be visible when you're ranging it. And they should be situated perpendicular to the range finding device as well. Now, if this thing's tilted, that base on your triangle is now, it's shorter because, it's a trig problem. Then you got more math to do if you can figure out the tilt. So if you're ranging a vehicle or a tank out in the field, and it's not situated at a, perpendicular to your position, that length measurement is not going to be very helpful because it's going to shrink. So it needs to be squared up with you. Another limitation is that it requires an extremely steady position in order to get an accurate mill reading of the target. As we demonstrated here, you're going to need to be deployed with the rifle, probably from your final firing position, probably your sandbag deployed in order to get steady enough to even get a mill reading. So you're going to have to be fully deployed with the rifle in order to even use this. With all these different limitations, and we're going to get into this in more detail here in a minute, this is only going to be relatively effective out to 700 yards for most applications of fire due to the high ranging error probability on smaller targets. So let's discuss some of the ranging error probabilities. What we're talking about here is if you're an expert with a mill-skilled reticle, for example, or a mill-dot reticle, okay, you're going to be able to measure pretty accurately down to 1/10 of a mil. Now, if you're a novice, if you're new at this, you might only be able to get within 1/4 mil, okay? So if we look at our different ranges and our different target sizes, let's say we're milling a 40-inch tall target at 500 meters, okay? And if you're 0.1 mils off at 500 meters, that's going to throw you off by 24 meters as far as your range estimation. So your ranging error probability at 500 meters with 1/10 of a mil error probability is going to be 24 meters. That means that you're going to get your range wrong plus or minus 24 meters, okay? That's not going to be very helpful. Now, when we look at the danger space at that range, 500 meters, we talked about danger space on the video before, so if you missed that and you don't know what we're talking about, check it out. But your danger space is you got a cushion of 77 meters before you start to have problems from getting a wrong range. So 24 meters is definitely less than 77. We're still okay. Now, if you were a novice at 500 meters, you're still going to be okay because even if you wiggle and you have an error of 1/4 of a mil at 500 meters, you're going to misjudge your range by 56 meters, which still fits into those 77 meters of cushion area you had with your danger space. Now at 700 meters, you're going to notice that this really starts to get closer because your danger space is now severely decreased, okay? And your range has increased, so it's going to be harder to mill. So now a 1/10 mil mistake is going to result in a 44 meter error. Okay, and your danger space is only 48, so you're pushing the envelope at 700 meters even if you're getting within 1/10. Now, if you land it exactly right on the 1/10, then it's going to be a lot more accurate. If you're a novice and you misjudge your mill reading by 1/4 of a mil, you're going to misjudge your range by 102 meters, which is over twice as much as your danger space, and now you're going to completely miss the 40-inch tall target, okay? That's going to be quite a large miss due to your error probability. And at 1,000 meters, you can see it's even worse. Your danger space is only 28 meters, and your error is exceeding your danger space, and at 1,500 meters is pretty much impossible unless you are a stud and have laser beam eyeballs and can discern exactly how many mils tall that target is. And that's the trick. However good you are at reading the mil scale is going to determine your effectiveness using this method. So this is something that requires a lot of practice. And you also don't want to get the size of the target wrong. Everything has to be just right in order for this to work right. Now you can see, like we talked about, if we look at the M19 binoculars or the M22 binoculars, they have the much more crude scaled reticle where they're in increments of 10 mils and the smaller ones are in 5 mils, okay? Even ranging a large target, which is what these are more designed for doing, or for directing artillery fire or things like that, more so. But if you're trying to range a large target, like we're looking at this T-55 tank sitting out here, and most of you probably know a T-55 tank. That's one of the most common tanks in the world there. And so you got you know your target size, and you plug that in. And if you misjudge your range in these binoculars because it's a lot more crude of a scaled reticle, now your error probability, an expert is only really going to be able to discern a 1 mil difference on that particular reticle just because it's so crude, right? So with a 1 mil mistake, at 1,000 meters, for example, we can look at the table here, you're going to misjudge your range by 156 meters with a 1 mil mistake. And your danger space to engage that target with rifle fire is 28 meters. So as you can see, the binoculars, the reticle in these binoculars is not going to be near close enough to be effective at 1,000 meters. At 500 meters, you're close enough. You're going to get within 41 meters. If you misjudge your range by 1 mil. And if you're a novice, you're really going to have problems. It's going to be dramatically worse. So the ranging binoculars are not really effective milling your target for purposes of range finding. Like we said before, they're more effective for other purposes. So you're going to want to keep that in mind. And there is one final limitation to using mil-scaled reticles, and that's that they take a little bit of time to get your range. It's typically going to take you 10 to 30 seconds to accomplish all this. You're going to have to lay down, you're going to have to mill the target, you're going to have to get steady, you're going to have to discern how many mils tall or wide the target is. Then you're going to have to look up how big the target is, its dimensions. You're going to have to plug it in the formula, and then that'll give you your range. And that can take, if you're real fast, maybe 10 seconds, or on some targets it might even take a minute or two to look up all that information if you don't know the target dimensions right off the cuff. Now, there are going to be certain times when you are going to want to use your ranging reticle. At a minimum, an optical trigonometric confirmation of any target's range should be performed when time allows. So if you have enough time to do it, you're not going to want to just trust your laser or your GPS readings alone. And we're going to get into that in just a minute here. But you're going to want to confirm all your ranges with an optical ranging system, because you're going to definitely get the right target bracket in there, and you're going to want to make sure your laser is actually reflecting off of the target itself, especially in certain situations where you might have a poorly defined background behind your target. So another situation where you're going to want to use a ranging reticle rather than a laser is where the use of a laser may risk enemy detection. So in those scenarios, you're not going to want to be shooting laser beam all over the place. You're going to want to be employing your ranging reticle if you're within a certain distance. And although reticles will have somewhat limited use at longer ranges due to error, the ranging reticle will be your primary ranging backup and confirmation method at the very least. So you better know how to use your ranging reticle. That's going to be very important. All right, let's look at lasers.